Hi, this is Bill Punch again with another video from Michigan State University on the topic, the practice of computing using Python CSE 231. This is a continuation, video 2 on the perfect numbers topic. We've figured out a way to collect all the factors of an integer. We're going to use the function that we created to do that so that we can classify a lot of numbers and see if we can search for perfect numbers. Let's go ahead and get started. So this was our collect factors function that we created the last time. This is version 2 up to the square root, and we showed that for even a fairly large number we get a really quick return of all the factors, the integer factors of that number. We now want to take advantage of that factor, of that collect factors function, and use it so that we can classify any number. We'll do it again in a function, and the function's going to take in a single number. And then we're going to use our collect factors function. We're going to pass the number to collect factors, the version 2, which is faster, and it's going to return our factor list, the list of factors of that number. We're going to use the sum function. Remember, we talked about the sum function in the tuples video, which basically goes through all the integers. The sum function, which goes through all the integers in the factor list and sums them up and restore it as factor list. And then it's a simple if statement. If the factor sum is equal to the number, we're going to return a tuple, which has as its first element a string, perfect, and the factors list. If it turns out that the sum of the factors is smaller than the number, then we'll return the string deficient in the factor list. Otherwise, it will return the string abundant in the factor list. So we've defined this function, and we are now going to apply it. This, as it turns out, this number is the largest number that was a perfect number known to about 1588 if you look at the web page I gave you before. Let's go ahead and run that and see how it works. And it says, in fact, it is a perfect number, and these are the integer factors that are part of it. And so if we were to sum those factors up, it would equal this really big number. Now that we have a classify number function that can return all the factors like we just did for a pretty large number, it would be great if what we could do then is search through a whole range of integers looking to see if we can find perfect numbers, because perfect numbers, as it turns out, are kind of rare. So we would like to see how quickly we can find a perfect number. And we'll use the function that we just wrote, the classify number function, to search for perfect numbers. What we're going to do is generate a number in the range from 2 up to something. I picked 10,000 to start out with. We will push that number into the classified number and get the tuple back. And the first element of the tuple, if it comes out as perfect, so if we check element 0 and see if it exactly equals the number perfect, then what we're going to print out are the factors for that number. Let's define this function, and let's then run it. And it comes back pretty quickly. For 6, here are the factors. For 28, here are the factors. For 496, 828, those were the ones that were known to the ancient Greeks. How long will it take us to go up to, and the next one occurs at about 34 million, to see if we can find that number as well. Let's see how long that might take. I interrupted the kernel at this point because it was taking clearly too long, and just as a check, let's just see how bad it was going to go. Let's make a count. Start at 0. Every time we go through, we're going to make the count go up by 1, and we're going to ask a question. If the count remainder, let's go by 100,000, equals 0. So anytime it's divisible by 100,000, let's print out count. And every time we go through the loop, we're going to make count go up by it'll give us a feel for how fast we're going in terms of getting things done. Let's redefine it. Let's make it start at 1. Let's define our function. Let's go ahead and run it. So I found the first pretty quickly. There's our first 100,000. There's our second 100,000. There's our third 100,000. So you can tell that getting up to 34 million is going to take us a little while.